Hey guys, today I'm going to talk about how to calculate how much hypertonic saline to give in a hyponatremic patient and how to calculate how much D5 you can give in order to fix overcorrection. So let's get started. The Adrogue Madias equation, I should have double checked before this video if I'm pronouncing his name right, but let's talk about the Adrogue Madias formula, because that is going to answer both of these two questions about hypertonic saline and how much D5 to give. So what this formula says is that to know how much a sodium is going to change with the fluids you're giving, that is going to be the sodium concentration of whatever fluid you're giving minus the sodium of your patient divided by your total body water plus 1. I'm not going to derive this. I may attach this in the notes if I feel like it later how to derive it. But this equation is key. Caveat is that notice that it doesn't include your urine osm here. And you can imagine if your patient has really dilute urine or their urine suddenly got really dilute, you're losing all this free water, and you're going to expect the patient's serum sodium to start increasing a whole lot because they're losing all that water. Your concentration, your patient's serum sodium is going to overcorrect. So you would think that the urine osm would factor into how quickly your sodium's changed. It's not in this equation. There are some formulas actually that have been proposed that do include the urine osm, but they don't account for like your urine osm is changing a lot. So caveats for this formula, I've read some people saying don't even necessarily use it, but it's at least a starting place that we can use for how to calculate how much hypertonic to give. So how do I use this to figure out how much hypertonic saline to give? So I have a patient, serum sodium is 110 milliequivalents. I decide I want to increase the serum sodium by 4 in the next 2 hours because they're really symptomatic. Maybe they're even seizing, they have cerebral edema. I want to correct it by 4 as soon as possible. So my example is patient serum sodium is 110, and I want to correct that sodium by 4 in 2 hours. How do I figure this out? So using the Adrogue Madias equation, so the sodium of the infusate, what's the sodium concentration of hypertonic saline? 513 milliequivalents a liter. If that's the first time you heard it, that's going to sound overwhelming. You're going to hear this again and again, especially if you're a renal cell. So 513 is the sodium of the infusate minus the sodium of the patient, 110. Divided by the total body water plus 1. What's total body water? For a male patient, that's 60% of their weight. For a female patient, 50% of their weight. If male, 50% of weight. If female. So suppose my patient's 70 kilos. He's a man. So 70 kilos times 60%, 0.6, and then plus 1. When you do the math here, plug it in, calculate it or approximate it in your head, which I prefer for you to start trying to be able to do, the number you're going to get is 9.37. I believe I wrote this down somewhere. My bad if it's a little bit off. So 9.37. Or sorry, computer. Let's just do 9.37. Let's not worry about the units here for a second, because you're going to get this number and be like, okay, what do I do with this? What this number means is that if you give 1 liter of your fluid that you decided, so for here we said hypertonic saline, that is how much your sodium is going to change. So 1 liter of hypertonic saline will increase my sodium by 9.37 milliequivalents. So let's turn this around a little bit. Let's just write that a different way. So to increase my sodium by 9.37, I have to give 1 liter of hypertonic saline. I don't want to increase my sodium by 9.37. I want to increase it. What did I say I wanted to increase? I wanted to increase it by 4. So to increase the sodium by only 4, not 9.37, I'd have to give about half. So because like 4 is about half of 9.37, so exactly how much would I have to give? Give 4 divided by 9.37, that's about 0.4 liters of hypertonic saline. So I said to increase my sodium by 4, I have to give 0.4 liters of hypertonic saline. Over what rate? Well, you decide on the rate. That's not what this equation necessarily is for. So you can decide. So if I wanted to increase the sodium by 4 over 12 hours, I just decided that for some weird reason, or like I don't know, whatever reason it was, I give 400 cc's of hypertonic saline over 12 hours. In this situation, I decided I wanted to fix the sodium by 4 in 2 hours. So that means I give 0.4 liters of hypertonic saline in 2 hours. Let's write that out. To increase sodium by 4 in 2 hours, give 0.4 liters of hypertonic in 2 hours. So 400 cc's of hypertonic saline in 2 hours. So you can use that's just 200 cc's of per hour of hypertonic saline in 2 hours. So we went over how to give how much hypertonic saline to give in order to fix the sodium. Suppose I have a patient who's overcorrecting, and now all of a sudden I don't want to give hypertonic saline. I decided to fix this correction, but re-lower the patient's sodium by giving D5. Really awesome thing is that you can actually use this same Adrogue Madias formula. So let me get my eraser. So I have a patient that I decided I want to re-lower sodium by 4. That's how much they overcorrected. He is also a 70-kilo male, and his sodium is 120. Sorry, let's do 120. And I'm going to use D5 to do this. So let's use the same formula. So sodium in the infusate. How much sodium is in D5? Nothing. 0. Divided by sodium of the patient. 120. Divided by the total body water. So remember that's 70 kilos times 60%. 70 kilos and 0.6 plus 1. I should have done this math before I came in. It says 120 divided by about 43. 120 divided by 42 plus 1. So that's about 33. Sorry. Told you have to be good at mental math, but I just messed that up. So 120 divided by about 40 is 3. So what does this 3 tell me? Remember, I said what this number tells you is that if you give 1 liter of fluid, that's how much your sodium is going to change. Just erase this so I have a little more space. Remember this number was 3. So 1 liter of D5 will decrease my sodium. It was a negative number, but also that also makes sense. Mechanism physiologically will decrease the sodium by 3. So, rewriting this, decrease the sodium by 3, give 1 liter of D5. I didn't want to decrease it by 3 though. I decided in this situation I wanted to decrease it by 4. So to decrease the sodium by 4 as opposed to 3, I got to give a little bit more D5. So you have to give 4 divided by 3. So about, or 1.3 liters of D5. How long do I give this over? Well, you could chose a scenario. You want to relower really quickly? You could give all that 1.3 liters in 1 hour. More for what you don't think your patient's going to tolerate it. So, or you were like, we could take a little bit more time to correct. No, there's no perfect science about how about this. There's a lot of data. But a lot of people end up doing different things. So if you want to immediately lower it, give 1.3 liters in the 1 hour. If you decide you want to give over 12 hours, the 1.3 liters of D5 over 12 hours. So if you want to decrease the sodium by 4 in 12 hours, give 1.3 liters of D5 in 12 hours. So what's the rate? Well, 1.3 liters in 12 hours, that's going to be a little over 100 cc's an hour. So 1.3 liters, sorry, really bad at saving space. So it's a little more than 100 cc's of D5 per hour times 12 hours. You guys see that? Okay, good. You could. All right. Hope this helps. Comment if you have any questions.